Hi guys, this is lesson 7-2, division properties of exponents. So at the top of your notes, make sure you're writing that right now, lesson 7-2, division properties of exponents. And we are going to cover quite a bit of material today, so get ready to take some really good notes. And I will try to simplify this as much as possible for you and let you get to practicing. On Monday, we talked about several different rules that help us deal with exponents. We talked about the product of powers, where if we have something like b to the third times b to the fifth, we're actually going to end up adding the exponents together so that we tell how many of the b's do we actually have. And exponents are actually a really nice way of writing something that would otherwise take up a lot of space. We talked about power of a power when we have exponents on top of exponents. And when we have b to the third to the fifth power, we actually have b to the third happening 5 times. We get a lot of b's there, and we find out that we could multiply those numbers, 3 times 5, to total those up to be b to the 15th. We talked about the power of a product, where if we have an exponent on the outside of a few things that are inside the parentheses, we're going to apply that exponent to every little piece. So a, b, parentheses, to the m would be a to the m, b to the m. And this is an example of a longer problem where we're dealing with applying the exponent to every piece inside the parentheses. So today we're going to talk about division. And so we're going to start with something called the quotient of powers. Quotient is a word dealing with division. Quotient of powers. And you are writing this down. And when we have the quotient of powers, we're talking about how we cancel things top to bottom. So notice if I have something like this, 2 to the 7th over 2 to the 4th, that would be something like 2 times 2 times 2 times 2 times 2 times 2 times 2. That should be 7 2s. Over 2 times 2 times 2 times 2. And so if we were just simplifying fractions, we would be able to cancel the matching 2's. 2 over 2 all by itself just equals 1. So when we cancel these, we're just leaving behind 1's. What's left here are 3 2's on the top, and we could represent that by saying 2 to the third. The pattern that we're noticing here is when we do all that canceling, we're actually doing subtraction, top minus bottom. And so what we could generalize here is that if we have something like a to the m over a to the p, this would equal a to the m minus p. Let's put something slightly more tangible to that. If I have c to the 11th over c to the 8th, this is going to equal c to the 11 minus 8. I could write 11 c's on the top and 8 c's on the bottom and cancel them all out. What I will end up with is 3 c's left on the top. Or here, let's do that with another variable. If I had r to the 5th over r to the 2, then I would have r to the 5 minus 2, or r to the 3rd. And again, visualize this. We are actually canceling the matching r's to show what's left. All right, so here's a little bit more complicated example to go with this one before we move on. Let's say I have g to the 3rd, h to the 5th over g to, gh squared. And if I wrote this out the long way, it would be something like this. G times g times g times h times h times h times h times h over g times h times h. And then you could see those cancel like this, leaving behind 2 g's on the top and 3 h's. So let's use the quotient of powers property instead here, and let's say that this is the same as saying g to the 3 minus 1. I'm going to say 1 because whenever there's not an exponent, it means there is a 1 there. And h to the 5 minus 2. Notice I'm doing top minus bottom. That's going to equal g, 3 minus 1 is 2, and h, 5 minus 2 is 3. And we end up with the same thing that we got when we wrote it out the long way. All right, let's move to the power of a quotient. So you're writing this down. Hopefully you're writing down as much of this as you can even get down. And this is what happens when we have something in parentheses. So we might have A over B, and then we have an M on the outside. And just the same as the one that we did on Monday, we will apply the exponent on the top and the bottom to each piece inside the parentheses. Another example of that would be something like this. R over T to the 5th is going to be R to the 5th over T to the 5th. Here's an example of something we might need to simplify using this. 3p to the 3rd over 7, all in parentheses, squared. And so that little 2 has to go with each piece of this. So we're going to say 3 squared, and then we have p to the 3rd squared, and then on the bottom we have 7 squared. 3 squared is 3 times 3 is 9. P to the 3rd squared we learned about on Monday is p to the 3 times 2, because p to the 3rd is happening twice, and so we'll get p to the 6th power, and 7 times 7 is 49. So there's our final simplified answer. When we're simplifying, we're trying to get rid of extra exponents and parentheses. All right, the next principle we need to talk about, property we need to talk about, is called the zero exponent property. So let's see, this is the third one we've talked about, right? So 3, 0, everybody's writing, exponent property. And what's happening here, I'm going to back up and just demonstrate something to you. Let's suppose I had 3 to the 5th over 3 to the 5th. That would be 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. And when I canceled those all out, each of those 3 over 3's leaves a 1, so I end up with 1 over 1, or just 1. If we apply the property we learned today, this would be 3 to the 5 minus 5, which would be 3 to the 0. So it doesn't become 0. What it becomes is 1. So the zero exponent property says that anything at all to the 0 power is equal to 1. So we might say a to the 0 equals 1. Or other examples, 15 to the 0 equals 1. Something like b over c to the 0 equals 1. Or something like 2/7 to the 0 equals 1. Anything to the 0 equals 1. All right, so we might run into something like this. X to the 5th, y to the 0 over x to the 3rd. And the part of this that says x, y to the 0 is just going to be a 1. So we can just sort of ignore that actually, and we will be doing the x to the 5 minus 3 or x squared, which is how many x's are left on the top after we cancel the 3 that are on the bottom. All right, the next thing we need to talk about is called the negative exponent property. Let's see, this is the 4th thing we talk about today. I told you there were a lot of things. Negative exponent property. When we see exponents that are negative, they are not negative numbers. The exponents, when they are negative, are just telling you that they want to be put in the bottom of a fraction. Or if the negative exponent is in the bottom of a fraction, it wants to be put in the top of a fraction. So I might have something like this, 2 to the negative 4. That will equal 1 over 2 to the 4th. And we could obviously multiply that out to be 1 over 16. Or I might see something like this, 1 over j to the negative 4. And that is going to be j to the 4th over 1, or just j to the 4th. The way I like to think about this is a negative exponent is unhappy. It doesn't want to live where it lives. It wants to move upstairs, or it wants to move downstairs. If you make it happy, then it's no longer going to be negative. So let's look at an example. I have n to the negative 5, p to the 4th over r to the negative 2. All right, so looking at this, n to the negative 5 is unhappy. It wants to go live in the bottom. It doesn't want to live upstairs. It wants to join the roommates in the basement. And when it goes down there, it's going to be happy. And so we're going to move it there. In fact, let's just redraw this over here. And we are just going to move it downstairs. And notice that as soon as I move into the negative 5 downstairs, the negativity goes away. It becomes positive. It is happy. Okay, so make it happy and the negative will go away. Look at p to the 4th. It's happy where it is. It's not negative at all, so leave it be. All right, now jump down and look at r to the negative 2. Is unhappy living in the basement, hates it down there. And so it wants to go live upstairs. As soon as we put r to the negative 2 upstairs, the negative goes away. It's happy and content, and there is no longer a negative sign, and we're done. All right, let me work a couple of examples here before I run out of time to show you some simplifying things that we will need to do. All right, I have t to the 5th, u to the 4th over t squared u. So I'm just going to do some housekeeping, tidy this up. I want to combine, cancel, whatever I can do so this is not so messy. Let's just deal with t first. Okay, don't try to think of the whole thing all at once. Just deal with t. This is t to the 5 minus 2 because I do top minus bottom, t to the 5 minus 2. Okay, I'll simplify that in just a second, but let's now change our attention to the u, and now we're going to do u to the 4 minus 1. I got the 1 because we just understand that if there's not any exponent, there is a 1. All right, I just need to tidy up this math. T to the 5 minus 2 is 3, and u to the 4 minus 1 is also 3. So I have t to the 3rd, u to the 3rd as a simplified expression. Yes, I could have written this out like this. I'll do it once for you. Takes a lot of writing. Over. And then I would cancel, cancel, cancel. Here are 3 t's, that's the same as t to the third, and here are 3 u's, that's the same as u to the third. All right, let me choose another one for us here. What if I have 2 n to the third b to the third over 3, all of this to the second power. So I have to apply the second power to every piece of this. I'm going to end up with 2 squared. I'm going to end up with n to the third squared. I'm going to end up with b to the third squared. And on the bottom, I'm going to have 3 squared. So we had to put that on everything inside the parentheses. Okay, let's tidy this up a little bit. 2 squared is 4. N to the third squared, we learned that a power on a power means we have to do n to the third twice, or multiply 3 times 2 is 6. And then we're going to do the same thing here. B to the third twice gives us b to the sixth. And then on the bottom, we have 3 squared, which is 3 times 3, or 9. And here is my simplified expression. I've gotten rid of extra exponents and parentheses. All right, let me do something with negatives. Negative 8, x squared, y to the 8th, z to the negative 3 over 12, x to the 4th, y to the negative 7th, z to the 7th. All right, so negative numbers are not the same thing as negative exponents. In this case, I want to think about simplifying the negative 8 over 12. There's no other numbers in the rest of this. Sometimes in the ones you were doing in Monday's practice, there were maybe 2 or 3 numbers and you needed to multiply them together to simplify this. But I'm only looking at a negative 8 and a 12. So I am going to just simplify that a little bit. They have 4 in common, right? Negative 8 divided by 4 is 2, negative 2. Don't lose the negative. And positive 12 divided by 4 is 3. And so the new numbers that I'm going to put here on top of negative 2 and on bottom of 3. Then I'm going to deal with the x's. I have an x squared on the top and an x to the 4th on the bottom. This is the same as saying x to the 2 minus 4. Okay, that's a little odd, right? Because 2 minus 4 gives me a negative 2. That's because x to the negative 2 will need to be in the bottom of the fraction. Okay, look, let's see if this makes sense here. Up on top, here, actually I'm going to do this. Up on top I have x times x, and on bottom I had x times x times x times x. So notice that if I was canceling, I would cancel 1, 2 of them, and 2 of them are left in the bottom. And whenever you just get a negative, when you do the exponent property there, the x to the negative 2 is going to mean that we want to put x squared in the bottom of the fraction. All right, let's deal with our y's here. I have y to the 8 minus a negative 7. Remember, top minus bottom, literally 8 minus negative 7. So I am actually going to end up adding the opposite, and I end up with y to the 15th power. Okay, does this make any sense? It does. This is getting a little messy here, but what I want you to see is that I had y to the negative 7 was very unhappy, and it wanted to go live upstairs with all its buddies upstairs. So here we have 8 y's that were living upstairs quite happily, and downstairs we had 7 very unhappy y's that wanted to go live upstairs with their friends, and that is why we have y to the 15th power upstairs now. Okay, let's deal with the z's here. I have z to the negative 3. I'm going to do the rule here for you. Z to the negative 3 minus 7. All right. Add the opposite, and you will get z to the negative 10. Okay, z to the negative 10 means that I want to put my z to the 10 on the bottom. Does that make sense? Let's see. Here, I had z to the negative 3, which means I had 3 z's living upstairs that were very unhappy. They wanted to go downstairs and live with these other 7 z's that were quite happy, and that's why now I have 10 of them down below. So we're basically sorting. You are going to make everybody happy. You're going to send the negative exponents to live either upstairs and be happy or downstairs and be happy, and then just represent everybody that's now living upstairs and everybody that's now living downstairs. I'm going to send you to Alex now to practice. You may end up with some questions. There's quite a few practice problems, and I also put a demonstration video for you in Google Classroom.